So the alternate segment theorem is actually done fairly well in the 10th standard Tamil Nadu book, but what it's saying is that if I have a chord that has a tangent here, then this angle is equal to the angle of the chord. So the angle of the chord is, you take it to any point, and we know that all these angles are the same. Any point you take, that angle, there will be an angle for the chord. So that this angle is angle 1, right? Then this angle is also angle 1. So for now I'm going to call it, okay, let's just call it, angle 2, right? And the proof of this is that if you take a point at the center and basically select that point, right, we know that angle is also angle 2. But because it's passing through the center, we know that this is 90 degrees. So I have a third angle here, we'll call angle 3. So I know angle 1 plus angle 3 is equal to 90 degrees. Why? Because any line from the center to the point of the tangent is perpendicular to the tangent. This we know. And because this is passing through the center, and this is the diameter, which is 180 degrees, and this is half of that, this is also 90 degrees. That also means that angle 2 plus angle 3 is equal to 90 degrees. So angle 3 is just a dummy for this proof, right? So basically it means angle 1 is equal to angle 2. Okay, so again angle 1 is the angle that the chord makes to the tangent, and the same angle, so angle 2 has basically become equal to angle 1, which is at any point on the circle what this chord makes in this part of the segment. The alternate segment theorem, this is basically part 1. Okay, so the part 2, I'm going to draw a separate circle for that, is that when I have the tangent and I have the same chord, now I'm talking about a different angle, which is this angle, right, is equal to the other alternate segment, which is this angle. These two angles are the same. That's what we want to prove. Okay, so we start with calling them different angles. Let's say this is angle. We already have this one, so I'm going to leave this with the chord. Okay, so I'll still call this angle 1, which we know, right? And angle 1 we know is equal to its alternate segment, so these two are the same. This we know already. So now what I want to prove is that this is, let's say, angle 2, and this is angle 3, and then angle 2 and angle 3 are the same. Okay, so now angle 1 is on the straight line here. So this angle 1 plus angle 2 is 180 degrees on line. This is on a line, right? Now angle 1 and angle 3 is also equal to 180 degrees. Why? That's a cyclic quadrilateral. Opposite angles add to 180 degrees. So again, you can see that angle 2 is equal to angle 3. Right? So this angle, angle 2, is equal to angle 3. Angle 3 is angle 2. So this is the alternate segment here. This is actually what is done even in the was not visible. This is what is done even in the textbook. It's just that we break it down to something simple that perhaps the children can follow more easily. If this part was not clear, angle 1 plus angle 2 is on this line, and angle 1 and angle 3 is cyclic quadrilateral. So angle 2 is equal to angle